All right, everyone, we're going to go ahead and get started. Thanks for taking time out of your busy day to join us. I'm Jenna Kirsten, a member of the marketing team here at Kirkpatrick Price, and your host for today's webinar. I'd like to welcome you to today's session on cloud security, where we'll be discussing the shared responsibility model, how to identify and manage cloud risk, and best practices for cloud security. We know there's tons of cloud security information out there, and we're grateful that you chose us today. Let's go over a few things before we dive into our discussion. All attendees will be muted throughout the session, but we do encourage you to ask questions using the Q&A feature, which is located in the WebEx toolbar. I will monitor those throughout the hour and have some time reserved at the end to answer those. This session is also being recorded, and all attendees will receive a link to the recording as well as a copy of the slides in your inbox tomorrow. Now, just a little bit of background about who we are before we get started. Kirkpatrick Price is a licensed CPA firm providing assurance services to clients worldwide. Our firm has over 13 years of experience in information assurance by performing assessments, audits, and tests that strengthen information security and compliance controls. We offer both regulatory compliance and information security services. We provide consulting services such as policy and procedure drafting, risk assessment, internal audit plan and development, and readiness audits. We also provide guidance and audit services on frameworks such as SOC 1 and 2, PCI, HIPAA, HITRUST, FISMA, ISO 27001, 27002, and GDPR. We also encourage you to connect with us by subscribing to our blog, visiting our library of on-demand webinars, and following us on LinkedIn, Twitter, and Facebook. Our speaker for today is Randy Bartels, Vice President of Security Services here at Kirkpatrick Price. Randy has a wide range of experience across IT disciplines and holds CISSP, CISA, CSSLP, and QSA certifications. Welcome, Randy.
Thank you, Jenna. I certainly appreciate the introduction and getting us started here. So before we go any further, our lawyers make us say give out the disclaimer here. I can't say it as fast as those guys on TV do, but this presentation is provided by Kirkpatrick Price for educational or informational purposes only and does not constitute any sort of legal advice. No attorney-client relationship is established in viewing this presentation. If you need any legal advice like that, please consult your own attorney. There, with that out of the way, let's talk about what we want to achieve this afternoon. Really just get a conversation started about cloud security risks. How do they compare against traditional IT risks? What's new? What's not? What's stuff that we've seen before? And how can we work more quickly through that so that we can focus on the stuff that is new? This is really going to be the heart of today's conversation. So how are we going to do that? Just laying out the agenda for this conversation. We'll spend just a couple of minutes defining the cloud, getting a couple of terms out there, what it is, what it's not, right? And then spend a little more time talking about how different deployment models and service models drive the risk equation. Because at the end of the day, securing the cloud is really about understanding the risks so that we can put controls in place that will allow us to manage those risks. So then we will talk about and identify a few of those risks and then some best practices around actually managing some of those risks that we've seen. And so as Jenna said, that will leave us with some time at the end as well for some questions. So please start putting those questions in as you think of them, and we'll save as much time as we can for the end. All right, real quick definition of the cloud. On the next slide there, someone once famously said, there is no cloud, just someone else's computer. That, I suppose, at its most basic and its most fundamental element is probably true. As we all try to put our head around what the cloud actually means, then we find out that quickly that it's a little bit more than just someone else's computer. So how is cloud computing actually being defined these days? We really have three principal organizations that we're going to be working off of material from them and research based on these three principal organizations really driving the cloud computing conversation. Of course, there are vendors who are out there in front as well, but we're talking about the standards bodies that are driving that. National Institute of Standards and Technology, part of the U.S. Department of Commerce, they've got some great material out there. Of course, ISO, International Organization for Standardization, they've got some other great materials both in the 27,000 information security series as well as in the back in the 17,000 as well. 17,889 I think is their definition of cloud computing, and they've got a glossary and some other things. And then really driving the security conversation around understanding risks and security practices is the Cloud Security Alliance, membership-driven organization that again is just really trying to bring a common set of conversations around what it means to understand risk and drive security into cloud deployments. So let's start with our NIST 800-145 definition. They give us 5 essential characteristics. These need to be present in some capacity, or you might have a service offering, but it might not be a cloud service offering. So let's just run through these very quickly. On-demand self-service. This means that you don't need an operator. You don't need somebody to go into the data center and partition out a new VMware instance or a new Zen server or whatever instance. Automated management and orchestration is the rule of the day. Broad network access. You can get to it from anywhere. Generally, you don't need any special network connections or anything like that to be able to get in and do your stuff. Resource pooling, this really is at the heart of it. This is virtualization that we have come to know and love in the 20-some years since VMware came out, and in the 50-some years since it was brought into mainframes and mid-range computers back in the 60s and 70s. Rapid elasticity, this is your Amazon auto-scaling groups and other solutions from other vendors. We're certainly going to refer to Amazon heavily. They own the significant lion's share of the public cloud market space, and so we will refer to them heavily throughout this conversation because it's a point of familiarity. And then measured service, you only pay for what is actually used, right? Cloud computing is simultaneously a transformative and disruptive technology, and the economists and the other people out there who have put those adjectives in front of different industry movements, it generally means that it's better, cheaper, faster, and especially on the cheaper, right? Because it's really those economies of scale that drive the disruption. And so we have seen this before. This isn't anything new. It used to be that Henry Ford, in the early 1900s, brought all of the raw materials to his factories and smelted the iron in order to, and then added the scrap metal and made the steel, and then bent the steel and shaped the steel and sent it over to, and the same thing with the engines and the tires and the wires and the everything else that goes into cars. We don't make cars like that. We don't make airplanes like that. If you watch one of those documentaries on how the A380 is made, it's really quick to see that other industries have been through this same transformation, and information technology is just the latest one, and it's really about specialization of skills, right? But what it does do, because it is transformative and disruptive, is it does require us to think about old problems in new ways. So what is that age-old problem? The age-old problem is we have something that we have to protect. You see he's got his crown on there, and so how do we protect this? We put him in the castle. We build a moat around it. We outer walls and firewalls and drawbridges and all these other kinds of things. And we put our data and our assets, and generally assets and data get tied very closely together in this paradigm, in the paradigm that we're coming from, and we put them all inside the castle, and then we defend the castle. Well, that doesn't work as well in in cloud computing because the castle is literally everywhere. So what is this the most fundamental element for us to understand is the shared responsibility model. And so in the shared responsibility model, we take all of our regulatory requirements, our industry requirements, our business requirements. This could be different laws that we have to comply with or different industry standards like payment card industry data security standard or ISO 27000, different governance models and contractual obligations and even just the need to solve a business problem using technology. All of these go into a hopper, and coming out of the bottom of that hopper is a set of requirements. In this case, we're going to talk about security requirements because this is a security conversation. And security at its most fundamental, the information security triad, confidentiality, integrity, and availability of data, and somewhere on this continuum, on this line of security requirements, the cloud service provider is responsible for some of them, and the cloud services customer is responsible for the rest. And this is the shared responsibility model. So let's, oh yes, and a very good important point to make here is that execution of individual security management tasks can be outsourced, but the accountability, the responsibility to see that they happen is always lies with the customer. So let's see this in play here in a couple of different, both in different deployment models and in different service models, and how that drives the risk equation. So deployment models, these are our private cloud, community cloud, and public cloud. This really comes down to who owns the assets and who consumes the assets. We're talking now about physical compute, storage, memory, networking resources, whereas on a private cloud, on the right-hand side, we end up with a situation where these are operated solely for the benefit of one single organization. That organization may actually manage those resources, or they may have a cloud service provider or private cloud operator come in and actually manage that for them. But on the left-hand side, we end up, where this is public cloud. This is Amazon, Azure, and many of the other public cloud offerings that we have out there. And in this case, these are made available to the general public, anybody who has the need to consume those resources. Community cloud is something in the middle, and we'll see here on our risk continuum that on the right-hand side, we end up with risks that are most similar to traditional IT outsourcing. These are third-party relationships that we have, and we establish strong contractual obligations, in terms of who's doing what, and there's an opportunity to influence that contract, certainly more so in private cloud than there is in public cloud. But the most significant risk that we end up with in the private cloud side of things is we can end up in a situation where dissimilar security requirements end up running within the same security domain, the hypervisor in this case, or the same storage domain, the same security boundary as something that needs more or less protection. An example, marketing needs to stand up a website, and so they request either infrastructure or platform as a service to make that available. Maybe that's that's through a WordPress site or something, and WordPress as a service, right? And that ends up running in the same hypervisor, on the same physical bare metal, within the same RAM and memory and other compute resources as the company financial accounting package, just simply by the nature of where that marketing request got sourced from. And so you can put controls in place to help manage that. But on the other end of the spectrum, we end up with risks of unknown fourth parties with an unknown agenda who are competing for the same physical compute resources. At least on the right-hand side, everybody's pulling generally in the same direction on the same rope. But in public cloud, it's not unlike living in an apartment building where you hope that your neighbors, and this isn't just the neighbor to the left and the right of the door when you walk out, right, into the hallway, but the one across the hallway, the one diagonal in both cases, the one that shares your back wall, the one above you, the one below you. You hope that all of those neighbors have, good hygienic practices, that they're not inviting the bugs in, but that they also don't have a strong burning desire to burn the building down. And so this is more of the risks that, and certainly the cloud service provider has to do more things, but just because they are under the obligation to do those things does not obviate the need for us as a cloud services consumer to also do the same. To take our protections all the way to the data, for instance. So let's see how oh yes, we have one more special case here for the person who's been through some of this introductory material before, right? You'll recognize that the hybrid cloud case has not been discussed yet. And in a hybrid cloud, this is really where we're taking any two or more of the other the other deployment models and putting them to use. And this also covers the very specific case where, especially during migration, but also extending into ongoing operations, where we connect our traditional data center, our Mott and Bailey castle, our fortress, and we connect that to the cloud provider. When we have a hybrid cloud, we are, the risks are cumulative based on the composition of the hybrid cloud itself. An example like this, let's take this traditional data center. We start off with our public cloud risks of, in this case, the one that we're using as our stand-in, is the unknown parties with an unknown agenda, and we add that to our private data center risks, and the combination of those two things together, we now have our hybrid cloud risks. And so an excellent opportunity here is anytime you have a mismatch in policy that meet at an intersection, we need to apply some policy, right? And that policy at its most fundamental element anyways, there may need to be more, but at its most fundamental element, that's a network firewall to help manage the risks between the two. And again, depending on the scenarios and the applications and the other use cases that you're putting in there, an application firewall may only be the beginning there. All right, so now let's look at how service model drives the risk equation. On the right-hand side, we have our infrastructure as a service, and and in this case, the cloud service provider is responsible generally for the physical security of the plant itself, and up to the point where they actually make that that hypervisor or hypervisor virtualized anyways resources available to the cloud services customer. And in this case, the customer takes over more responsibility of the technology stack, as we'll see in a slide or two here. And then on the left-hand side, we have software as a service, and in this case, the cloud service provider is providing a turnkey solution. It's really their obligation to manage the entirety of the technology stack. When up to the point where they make an interface available, and the cloud services customer brings their data, right? And platform as a service, this is really where marketing departments have gone wild because, I think I actually just saw it yesterday. Everything as a service, EAAS, and so they want everything as a service because cloud is really, really hot. But this could be, your AWS Lambda, or JBoss as a service, Python. Developers bring your code. It could also be your remote database or your distributed database, MongoDB, RDS, Azure SQL Server, Azure deployments, right? These are really all examples of platform as a service. Software as a service, pretty easy to define what that means. Infrastructure as a service, equally, straightforward. But platform as a service is really where all the variability is at, and we'll see that here in just a minute, right? So let's go to the next slide, and we're going to turn this arrow on its side. On the right side of this slide, we have our technology stack. about the only thing that's new here to cloud computing over traditional data center is virtual machines, virtual network hypervisors, right? That stuff right there in the middle, right? Now, this is a typical infrastructure as a services cloud stack, right? And in this case, the cloud provider is always responsible for security of the cloud, and that's actually the way you'll see that material from Amazon and from others, right? Security of the cloud, security in the cloud. The cloud services provider is responsible for everything below the line. In this case, hypervisors, processing and memory, data storage, network interfaces, and facilities and data centers, physical security, right? And the cloud customer is responsible for everything above the line. And so what does that mean to be responsible? Well, over there on the left, we really just, this is just for those who, some of you may have recognized this as just a summarization of the, in fact, in the same order as the PCI Data Security Standard. It's just one way to secure stuff, right? But it's all the things that need to be done. And when we're talking about security of the cloud, security in the cloud, we can see when we put this technology stack on its side and stand it up like it belongs, that both parties have an obligation to protect the network. The security provider, the cloud services provider, needs to secure the physical network, the data storage, the actual routers and switches, the top of rack devices and whatnot that are sitting at the top of the top of the rack in their own data center. And both parties have an obligation to manage configuration securely. The cloud service provider needs to harden the hypervisor, and the cloud services customer needs to harden their virtual operating systems and make sure that their virtual networks are set up properly. And so on and so forth. So both parties have a responsibility to do all the stuff on the left in as much as it applies to their area of the stack on the right. That's the difference between a cloud services, between the shared responsibility model and a cloud services conversation and how we have operated it traditionally in our single-use data centers. So let's look at how that changes when we go to platform as a service. We just move the line, right? So now the cloud services provider is responsible for the middleware, for the database, for the Python implementations and the JBoss and the whatever else goes into that middleware that they're providing as a service, right? And then as the final example, when it's software as a service, the cloud customer is now really left with the responsibility to execute and to implement the configuration that secures the interfaces using features that are made available by the software as a service provider, and then to also bring their data, right? And so this is the shared responsibility model when we look at it from a technology stack. Now let's look at a typical cloud services supply chain. So many of the people that we work with on a regular basis in our business, they are that service organization. They're with the dark gray. I guess they're in the dark gray cloud there, right? The service organization, and they are providing a service to their customers. And in this case, we're using SOC 1 and SOC 2 for those of us who live in that space. You'll recognize those, right? We're using terminology from SOC 1 and SOC 2, service organization and user organization. And so to the user organization, everything looks like a cloud. But to the service organization, they're getting compute resources from Amazon, from Microsoft Azure. They're also consuming storage resources from Elastic Block, or maybe from S3, or Amazon RDS, the database service, or Azure SQL service. Right? They could be getting it from somewhere else too, right? And then because all of this solution needs some way to be backed up, they turn to a backup service provider, who themselves is a cloud service provider. and they are consuming, Google Compute resources and Amazon S3 for object storage, or maybe Glacier, right, as a long-term storage solution through Amazon. And then finally, maybe this service offering that the cloud service provider, the service organization, is providing may have actual physical infrastructure located at Rackspace or any other data center, I/O, or any other data center for that matter, right? But yet to the user organization, it's all cloud. But in this case, the service organization is consuming cloud services to provide cloud services, and so that puts them in the cloud services supply chain. And so the risks that we talk about in terms of a cloud service provider and a cloud services customer, in both sets of these risks apply to that organization. They need to do the things that are smart to do in consuming and also in providing those resources. So let's move here on to the next one. Just a couple of examples of showing this shared. These are just direct, screenshots right off of Microsoft Azure and Office 365 documentation, Amazon Web Services, and you can see they generally present this as a technology stack with a line. They're responsible below the line, and we as cloud services, customers are responsible above the line. All right, so let's talk about a couple of best practices in working through the shared responsibility model. As a cloud services provider, consider these risks that your customers, consider them from your customer's perspective, right? This unknown unknowns of, fourth parties with unknown agendas, right? Consider that from your customer's perspective, and then implement controls that will alleviate that, or certainly demonstrate that you're doing everything that you can in your position as a provider to alleviate those risks. Document those controls that you will be using to manage those risks, right? And provide also ample documentation on how your customers can use the security features that you provide in your platform. Amazon does an excellent job of this, and with their different educational outreach programs and whatnot, you can get a wealth of information as somebody consuming, whether it's basic infrastructure as a service or all the way up the technology stack, on how to make the most of the features that they provide to you. Create a responsibility matrix as a service provider that shows how your solution will help your target customers meet their compliance obligations. This might be a PCI security, responsibility matrix that shows the controls. We got an example of that coming up here. It could be any other security management framework, ISO 27000, HIPAA, HITRUST. The list goes on. It's just alphabet soup out there when it comes to that. But prepare that responsibility matrix, because your customers are going to need that, right? They're, as well in their preparation of their own documentation of the same regard. And then, turn to the Cloud Security Alliance. They have a consensus assessment questionnaire. They call it CAKE. I guess it's supposed to be a piece of cake, but then also the Cloud Controls Matrix. These are excellent starting points as you think about where you're going to draw the line in establishing the shared responsibility model as a cloud service provider yourself, right? As a cloud services customer, define your cloud security requirements before you go into looking for a cloud service provider. You're not going to find everything that you want, but if you know what you're looking for before you get there, you'll be able to, prioritize and stack rank the different providers that you might be looking to for your solution, and then you know that you're just going to have to cover the rest of the rest of the distance, right? Harmonize your corporate governance program between both traditional and cloud-based IT delivery. What do we mean here? Moving information, moving systems and applications into the cloud is going to cause a difference in policy. And your information security management program, your ISMS and ISO 27000 speak, is not going to keep up unless you work on that ahead of time, right? You will end up in situations where you've got to do something that policy doesn't permit unless you've thought through that ahead of time, right? And so then, establish contractual clarity on the roles and responsibilities of each party, especially when you get into public cloud. This is more about you understanding where they stop, because you're not going to get to redefine their service levels in a public cloud provider, right? Just being realistic, right? So this is about establishing clarity amongst yourselves on your team as you bring solutions into the cloud, on who's responsible for what, how far does the service provider go, and how far do you have to carry the ball after that, right? And then finally, develop a responsibility matrix that defines the security roles and responsibilities that both you and each of your cloud service providers are going to be responsible for. What does an example of that look like? So here on the next slide, we've got a sample requirements matrix. This is actually a requirement for PCI. If any of your customers, as a cloud service provider, are beholden to the PCI requirements, they have to create a responsibility matrix that takes the individual PCI requirements and it defines who's responsible for what and how much further do you have to go as the eventual end customer who has the obligation to protect the data. And so this literally just going down the left-hand side is all of the requirements that need to be met, and then going across the top is each of the parties, yourself, our generic Acme Corp, plus each of the service providers, cloud service providers in this case, that you are consuming resources from. All right, so let's shift gears and let's talk about some cloud security risks and try to put some very specifics on it here. The European Union Network Information Security Agency, ENISA, the acronym works out in French, I guess, but a couple of years ago, they updated an older document that they had started, back in 2010, 2012 area, and just to bring shed some light on what some of these risks are. The most of these things that are on this on this slide, these are not new, right? Management interface compromise. We'll talk about that here in a minute. Malicious insider. We've had risks from malicious insiders. A trusted system administrator going rogue. That's been a risk, for as long as we've had data and systems, supporting business, right? Isolation failure, we have isolation failure when our perimeter-based security model fails and the virus gets in anyways, right? But this one in the middle, protecting data, why is that one different? Every other organization who has done these surveys, ISACA, ISC Squared, Security Magazine, InfoSec World, whatever all the different publications are and industry groups are out there who have done surveys of people who have started moving information into the cloud. The one thing that comes back most consistently as the number one item is I am concerned about my data being in the cloud, that I might lose the confidentiality, integrity, or the availability of my data. And so that one continues to be number one, but the rest of these may be loss of governance and cloud customer connectivity. These might be mostly unique to moving information and consuming cloud resources to provide applications and services. Loss of governance, the cloud service provider doesn't do something that because of their position, they're the only one who can do it, right? And then cloud connectivity problems. If all of our information and our applications are in the cloud, what happens if we lose internet connection as an organization? Suddenly the whole business is down. Is that, and so now coming up with solutions to try to mitigate that risk, right? But all the rest of these have a traditional data center feel to them as well. So we'll talk about a couple of examples of these here on the next slides, actually. So now let's talk about some actual cloud security best practices. We'll lay out, how we achieve this task as in traditional data center, what some of the nuances are as we move it into the cloud, and maybe what some of the best practices are as well. So the first one, reusing credentials and securing the management interface, right? The traditional practice, this is the way that credential reuse and protecting the management interface, these are some of the practices that we've had in traditional data centers. The first is, that we might use the same local administrator account on all deployed workstations, and we might even use a different one on all of our servers. This is the local admin account, not the domain admin account that exists in the domain controllers, but the one that exists in all of the local security account managers on each of the member servers and all of the workstations, right? Same password all the way around. So bad guy breaks in and steals the password hashes off of one, he's got access to everything. And another way in which we see this in traditional data center deployments is that we grant our domain administrator permissions to our daily use accounts. The same user account that is used by the domain administrator to read her email is the same one that is used and to browse the web is the same one that is used to create users and change permissions and perform database administrative type tasks, right? And then, a third example of this is that we've got a service account, let's call it the backup account, right? Because the backup software has to log into all the servers and back everything up, right? And so that service account has a static password because to change it would be a huge pain in the, it would be a lot of work. How about that? But the backup account has to log into all the systems in order to do backup-y type things. And so that static password never changes, and yet it also has domain administrator permissions to be able to log in and do all the things, right? So how do we take this, this is how these same things, these are real practices that we've seen in our audits and in our penetration tests, right? That somebody will take the same SSH key because our favorite, cloud services infrastructure provider makes it easy, and you gotta be able to log into the system some way. And so part of starting up an EC2 instance is, which key do you want me to put on the user? But then we never change it. And in one instance, we actually saw one of our pen testers got access to the email server and was browsing through the emails, and there's the SSH key. It got emailed to everybody. And so there it is, right? Another example of this is that we use the root or the administrator or some other privileged account that is used for managing the console, in this case, for creating new cloud resources, standing up new instances, changing our VPC or our security group configurations, right? And so that same root account is used for everything, right? And instead of getting locked away and then using individual user accounts, right? And then finally, the third example of this is that we assign an access key to an individual account, usually the root account, right? And then we reuse that key in all of our scripted automation tasks. And that key is as good as a password, but yet it's stored on a hard drive, right there in the API configuration, in the command line interface configuration for accessing the API. So let's talk about some best practices to counteract some of these risks, right? Avoid using the default root account. In fact, take that root account, buy the hardware-based multi-factor authentication token from Amazon, and then put that hardware-based MFA token in a locked safe somewhere, right? That is your break glass in case of emergency, back out method. But you don't use it on a day-to-day basis. Don't put an access key on it. Don't do any of those things. Do not use that account, right? It has the permissions to do everything, and it can't be blocked out, right? Require that all users who access the management console use multi-factor authentication, whether they're a developer or whether they're a full-on system administrator or a billing administrator or anybody else for that matter, different roles that you can define in these different management consoles. Require that each one of those use multi-factor authentication instead of just a static password. And you can use the soft tokens there. Pretty much everybody out there supports some form of soft token using Oath protocol or Authy or something else, right? And then assign policies. And policies in some of these consoles, these are the permissions, right? So assign policies to specifically only to groups or to roles, never assigning policies directly to users, right? This is akin to how we manage Active Directory. We have a domain administrators group. We have different role-based access control groups, right? RBAC, right? And then we just make users members of the groups. And this is the same thing in cloud, in managing our cloud consoles, right? Require that all console-based accounts assert a role. So, for instance, if they want to, if somebody logs in and they need to, they need to manage an EC2 instance and terminate or start a new one or whatever, right? They should have to assert that role first. That creates a log entry that they asserted the role. Plus, it also gives you an opportunity to validate that it really is a true live human, that nothing else, that before they gain access to these super user permissions, that you check and make sure that that they did authenticate by way of multi-factor authentication, or that they're coming from a known good, that they should be coming from your data center, right? Or they should be coming from your firewall to NAT address, or what you can do different. This is called attribute-based access control, ABAC, which is role is one attribute that can be managed, but it's not the only one. Whereas in our traditional data center, we rely heavily on role without relying significantly on other types of attributes, right? And so setting up attribute-based access control at the time that somebody asserts a role to gain the additional permissions that they need to do their thing, that is an excellent way to create a log entry, plus it is an excellent way to make sure that it really is the human that you think it is, right? And if you need to take API type of activities, you need to call the S3 API to move some data on or off of S3 to work with it, right? Assign those roles to the instances that are going to be working with the data. That's a thing in AWS, right? Assigning the role to the instance. Don't use the access key. In fact, there's probably no, try not to create access keys if you can possibly avoid it, because they're as good as the password. And, yeah, they're long and complicated and randomly generated, but they're as good as the password, right? And then finally, within your actual instances inside, if you're running infrastructure as a service, for instance, when you get ready to log in as your user account, because of course we don't log in as root to our instances either. When you get ready to log in as root, or not as root, as a different user, as your own user account, maybe you'll assert the role of root later after you get logged in with sudo or whatever, right? But require multi-factor authentication before you can get access to privileged accounts within the instances themselves as well. We're talking like shell access and things like that. But that also goes for, in a software as a service type of a platform. If the software as a service provider provides the ability to use multi-factor authentication on your administrator accounts, do it, right? It's definitely worth the additional complexity of having that solution in there. So let's talk about the next example here. In this case, managing secure configurations. The traditional challenge is that patching and hardening of production systems is time-consuming and disruptive, and those systems are in production, and we've got to take them down to patch them and reboot them. So now we need change windows, and we need lots of teams or people or tools or both, right, in order to get this done. So significant infrastructure and resources are required to stay on top of it. In this approach, we're really saying that our infrastructure are pets, right? And we care for them and we feed them. If anybody's not familiar with the infrastructure, our pets analogy, I'll actually finish that up after we go through the second side over here. So how do we rethink this particular challenge for cloud, right? You don't necessarily need to bring this approach to production system management into the cloud. In fact, if you go with a lift and shift and you call it done, right? You just lift your production app apps out of your traditional, castle-based infrastructure, and you move them into the cloud, you haven't considered the risks that are involved in changing platforms. The cloud presents a different set of risks that as we've already talked about. In those applications, say for instance that application is built on a platform of SQL Server, with transparent data encryption. That may not be enough in working with the cloud, or maybe the cloud platform that you've chosen doesn't even support TDE because of the additional processing requirements that are needed for that. So to gain these advantages, many times these applications will need to be transformed in order to bring about this. And in this case, what we're really talking about is infrastructure our cattle. So to finish out the analogy, infrastructure our pets, they have names, and cute names maybe even, right? The infrastructure, the email server's name is Bob, and he comes over for dinner, or he sits on the couch and he eats food from your hand. I mean, because these are what we do when we're taking care of our pets, and when they get the sniffles, we rush them down to the vet. And if it's after hours, we pay the emergency vet fee, right? But yet, if our infrastructure are cattle, and the cattle gets a little bit of a sniffles, what do? We make room in the freezer, right? Because we're going to get some more hamburger, and so we shoot the server, and we let it, and we let the cloud infrastructure take that over. So let's show what that means here. So in our traditional deployment process, this is a simplification of it, right? But we prepare the infrastructure, we harden the infrastructure, we patch the infrastructure, we harden and patch the applications, then we test for security, and then what do? We monitor and we maintain it forever, which means we go back and we harden and we patch it, and we harden and patch the apps, and we test it for security, and then when security doesn't meet snuff, we go back and patch it and we harden it, and it just goes in this cycle forever, right? And we have to do this for each and every server. If we have a email server cluster, we have to touch each one of these servers every single time, right? So how does this look in a cloud-based deployment model? Well, this is called shifting left with immutable workloads. We develop our software, we prepare our infrastructure, we harden and patch the operating system, we harden and patch the applications, we test it all for security, and then what do? We package it for deployment. We build this into our master image, right? And then what do? Well, this is the cattle part. We kill off all the previous, production instances, and we let the auto-scaling groups and the load balancers and the virtual infrastructure start up the new ones that it needs. And if any more effort is needed, the next time that we need to patch that operating system, the next time we need to make a configuration change, we feed it all back into Jenkins or whatever our continuous integration platform is. And then we package that for deployment, and we kill off this instance, all the production instances of it, and so we only have to patch and harden and maintain one image as opposed to 20, if that's what our production traditional infrastructure looks like. So shifting left with immutable workloads presents us with a way to get a force multiplier when we move our applications to the cloud. So now in our last example, system logging and monitoring, the traditional challenge is that the analysis and retention of this log data, for instance, in PCI, thou shalt keep thine logs for up to a year, all of your logs for up to a year. That can easily overwhelm, your traditional logging and monitoring solutions, right? And certainly overwhelm the IT resources, because those things have to be looked at every single day, right? And so system troubleshooting and administration activities requires privileged accounts on the production machines themselves, right? So if you steal the account, you get access to the account, you get all the data on it, right? Then when we consider, the continuing blend of development and operations, we're calling it DevOps, right? That blurs the line between the separation of duties on production systems. Now the system administrator, out of the IT operations group and the lead developer both have root accounts, or the ability to assert the role of root on our production databases and web servers and whatnot. So how do we rethink this one for cloud? Well, object-based storage is fine as a retention point for logs, and it's comparatively less expensive than going out and buying a bunch of hard disks, right? And once you get to the point in your log retention maturity, you can move those over to long-term storage. Glacier and some other solutions that are out there. Glacier is Amazon's long-term, doesn't need to change much here, folks, data storage point, right? And then we've got cloud security as a service providers who would be happy to come in and take care of that and do that monitoring and analysis for you and alert you anytime something funny happens, right? And they all work with cloud, so you can get that log monitoring solution in place in pretty quick order, right? And again, when infrastructure is cattle, then production access, like your SSH, is many times you don't even need it, right? And so the DevOps can now work through the continuous integration approach, right? They monitor the logs for things that need to be fixed. When something doesn't quite work right, they go look at it through a robust logging and monitoring system, like we've already talked about. They fix it back in Jenkins or whatever your or Chef or whatever your continuous integration platform is. And then you go out and shoot all the cattle, right? And the infrastructure comes all back up on its own, properly sized for the current workload, based on the new image. So those are three different, best practices around, security operations and risk management in the cloud. So let's just summarize what we talked about here, and then we will open this up for a few questions for the balance of the hour. So the transformation to cloud computing is not anything new, right? But it is disruptive within our industry. It's new to our industry, right? But and it is disruptive to the way that we've been thinking about our security problems and solving security for the castle, right? And so the shared responsibility model is absolutely critical to understanding and working through the cloud security risks that are out there and coming up with controls that mitigate risk. The deployment and the service models, they change the risk profile for both cloud providers and for cloud customers, and when the party is both, right? But understanding how the risk equation changes for deployment service models, very important. And then finally, cloud-based delivery models require new ways of thinking about IT delivery practices in general. Whether that's re-architecting our application rather than just lifting and shifting and calling it done, or some of the IT security operational things like patching and hardening and logging and things like that we talked about. So with that, I think that takes us to the end. And so you have my contact information there. If you have any questions you didn't think of that we didn't get to today, we'd be happy to hear from you. But Jenna, I'll open it back up to you for questions.
Yeah, we'll give everybody a second. I know I've been busy taking notes, so I know everyone else probably has too. Even if it's a super specific question, Randy can do his best to answer that. And like he said, his contact info is up there, and you have mine in your inbox too if you think of anything we haven't asked yet. Just a reminder, you will receive a copy of the slides and a recording of this webinar tomorrow in your inbox. You can share it with whoever else you think might want it and re-listen and keep on learning. And with that, we're not getting any questions in. I think you've covered everything too well, Randy. You've given us a lot to think about. And like I said, please email Randy or myself if you have any further questions. We're going to have a couple more webinars coming up in the next couple months, so keep an eye out for my emails on a bunch of different topics, including GDPR, among others. So with that, I'll give you back the rest of your hour. Thank you so much, Randy. That was amazing content. I learned a ton, and I know everyone else did too. Have a great rest of your day.